Let me describe to you how I calculated wind aloft and estimated departure time in JAFB. So at the very beginning, we're having this RFS data source, which stands for Rapid Refresh Forecast System, which basically represents a grid layout covering the whole North America. And each grid represents 15 kilometers by 15 kilometers square in our case. So for each grid, we're having different parameters attached to it, basically different pressure levels. And for each pressure level, we're having east-west wind component, north-south wind component, temperature, and geopotential height. Why are we having height for each pressure level? Because pressure by itself doesn't define altitude mean sea level. So that's our beginning, what we have at the beginning. Then we have in departure and destination airports. So we need to build a great circle route between them, and then we need to split this route into a lot of small segments. For example, now I'm using 6.5 nautical miles for each segment. So for each segment, we have a start point and end point. And we have in the distance. And for us to calculate estimated time arrival, we need to calculate ideally ground speed for each small segment. And since we're having these wind components, we can calculate tailwind and crosswind components for each segment. And using true airspeed, we can calculate this ground speed. So using ground speed and distance, we can calculate the time that it takes for the plane to fly this, will take for the plane to fly this segment. And we can summarize all these timings together, and we'll get estimated time arrival. Also, if you looked at the tool result, I'm showing the trends for crosswind components and tailwind components and temperature. Also, why? Because, for example, if we have 80 segments, for each segment we can have different crosswind components, so they can fluctuate. So, for example, I'm doing wind correction angles. I'm representing them in a tool result because I think it's better, because crosswind can be different direction. And for tailwind and headwind, also I'm using these trends and also checking out which segments in this whole route are headwind mostly or tailwind. And for crosswind also I'm finding out the segments with 5 or 10 or 15 degrees more correction angle. And for temperature also I'm showing the trend and also showing freezing levels, like the segments where the temperature is below 0 Celsius degrees. But it will be useful for us later, because when I'll be integrating also icing functionality. So that's all.